What if you could build a smart auto cutoff battery charger using only a few simple components? This circuit will automatically stop charging when the battery is full, and it also gives red and green LED indicators for charging status. Let's build this simple and powerful 12-volt battery auto cutoff charger circuit. First, let's look at the components used in this project. We need TL431 adjustable shunt voltage regulator, 1K ohm quarter watt resistor, 1.2K ohm quarter watt resistor, 10K variable resistor, 2 push buttons, 10K ohm resistor, 3.3K ohm resistor, green LED for full charge indicator, red LED for charging indicator, IRF Z44N MOSFET, 6 amp rectifier diode. The TL431 component is taken from an old PC power supply, but you can also buy it easily from the market. First connections, resistor network. First, take the 1K resistor and the 1.2K resistor. Connect one side of both resistors together. After that, connect TL431 pin 1 to the 1.2K resistor, TL431 pin 3 to the 1K resistor. Variable resistor connection. Now take the 10K variable resistor. Connect variable pin 1 to TL431 pin 1. Variable pin 2 wiper pin to TL431 pin 2. This variable resistor will help us adjust the charging voltage level. Push button connections. Now take the first push button. Connect it between TL431 pin 2 and pin 3. After that, take the second push button. Connect it between TL431 pin 3 and the junction of the 1K and 1.2K resistors. LED indicator connections. Now we connect the charging indicators. First, take the green LED with a 10K series resistor. Connect it at the same point where the second push button is connected. This LED will show battery full status. Now take the red LED with a 3.3K series resistor. Connect it at the same point where the first push button is connected. This LED will show charging status. MOSFET connection. Now take the IRF Z44N MOSFET. Connect MOSFET gate pin to TL431 pin 3. MOSFET source pin to TL431 pin 2. Diode connection. Now take the 6 amp rectifier diode. Connect the diode anode side to the junction of the 1K and 1.2K resistors. Also make sure to use a heatsink with the MOSFET because it can handle higher current. Power supply connection. Now we connect the power supply and battery. Connect power supply positive to the diode anode side, power supply negative to MOSFET source pin. Now connect the battery. Battery positive to diode cathode, battery negative to MOSFET drain pin. Adjustment. As shown in the video, with the help of the variable resistor, you can adjust the charging voltage level depending on your battery requirements. Circuit working. Now let's understand how this circuit works. The TL431 works as a precision voltage reference and controller. When the battery voltage is below the set level, the MOSFET allows current to flow and the battery starts charging. At this time, the red LED turns on, showing that the battery is charging. When the battery voltage reaches the preset full voltage level, the TL431 changes its state and turns the MOSFET off. This automatically stops the charging process. At this moment, the green LED turns on, indicating that the battery is fully charged. Reset function. If needed, you can reset the circuit using the push button. But remember one important thing. Do not press both push buttons at the same time, otherwise the circuit may not work correctly. Circuit uses. This circuit is very useful for many applications: 12-volt lead-acid battery charging, solar battery charging systems, DIY battery charger projects, UPS battery charging, battery protection circuits, automotive battery charging. It helps increase battery life by preventing overcharging. If you like DIY electronics products like this, make sure to like this video, comment your questions below, subscribe to the channel for more electronics experiments and circuits, and I will see you in the next project.